Okay. It content or enthalpy of system. Every substance or system possesses a definite amount of energy known as internal energy. You in thermodynamics, a system may also perform pressure volume work, particularly during expansion or compression. Since this pressure volume work represents another form of energy associated with the system, it becomes necessary to define a new thermodynamic function that accounts for both internal energy and PV work. This thermodynamic function is called enthalpy. It is defined as H equal to U plus PV. Thus, enthalpy represents the total heat content of a system under constant pressure conditions and is especially useful in describing energy changes in the chemical reactions and physical process occurring at constant pressure. Most experiments in the laboratory are performed under constant pressure, atmospheric pressure, rather than the constant volume. In many chemical reactions and physical processes, a change in energy is accompanied by a change in volume. For example, when water is heated in the beaker, its internal energy increases because it is supplied to the system. At the same time, the water undergoes expansion, increase in volume, therefore the heat supplied to the system is used in two ways: to increase the internal energy of water, to do expansion work against the external atmospheric pressure. Thus, at constant pressure, the total heat supplied to a system is utilized both in increasing internal energy and in performing pressure volume work. This is why the concept of enthalpy is especially useful for process occurring at constant pressure. According to first law of thermodynamics, dq equal to d plus w. Dq equal to d plus pdv. dq infinitesimal quantity of heat absorbed by the system, the infinitesimal increase in internal energy of the system, dv infinitesimal increase in volume at constant pressure. At constant pressure, equation first can be expressed as dqp equal to d plus pdv. As soon as the system absorbs dqp quantity of heat energy, the internal energy of system increases from E1 to E2, and the volume increases from B1 to B2. So D equal to E2 minus E1, dB B2 minus B1. Putting the values of D and dV in equation second, we get dqp equal to E2 minus E1 plus PB2 minus B1. So dqp equal to E2 minus E1, PB2 minus PB1. Also, you can write dqp equal to E2 plus PB2 minus E1 plus PB1. E, P, and V, energy, pressure, and volume are the state function. So the quantity of E plus PV must be state function. This thermodynamic quantity, E plus PV, is called total heat content of system or enthalpy of the system. And it is represented by the symbol as, that is, H equal to E plus PV. Hence, enthalpy in means in and enthalpos means heat of a system is defined as the total heat content of the system if S1 and S2 are the enthalpies of the system at initial condition and final condition, then S1 equal to E1 plus PV1 and S2 equal to E2 plus PV2. Now equation third change into dqp equal to S2 minus 1. So dqp equal to ds. In terms of finite change, dqp equal to delta H. From equation by, enthalpy change of a system is equal to the heat absorbed by the system at constant pressure. The first of thermodynamics change is H dqb equal to d plus pdv at constant volume dqb equal to d. In terms of finite change, equation 7 becomes qv equal to delta E. Equation 8. According to equation 8, internal energy change of system is equal to heat absorbed by the system at constant volume.